Welcome. This is a brief video on the use of files when we do our test programs. In order to manipulate files in the test program, we must use features of Unix for manipulating a file. We see on the window at the bottom that there are two files that I'm going to use in my demonstration. These files also are within the public repository. So if you say op status Unix, you will see those two files. And you can get these files out and use them as an example. And you can live a lot of the things that we see, especially in the CPP file, into your code and modify it. So let's take a look at the echo command. In Unix, the echo command really means display something. So I can say echo fat cat. And what do we see? Fat cat is displayed. So we basically send something to standard output, which is the screen. I can actually put commands together. I can say echo good, echo dog. Notice that the delimiter or terminator of a command is a semicolon, and now I have actually issued two commands. The first command issues the output good, the second command dog. If I want to put both the outputs on the same line, I would have to say echo hold the line feed, -m says no line feed. I say good, and then echo $n dog. What happens there? Well, didn't do what we wanted because we have good and dog and still no line feed. So what should we do to correct that? Well, let's try this. Echo in good. That produces a line that has good on it but no line feed. If we now want to say dog, we say echo dog. That gives us the line feed. Still not happy because we still have both of these stuck together. So let's try it one more time. We're going to say good. I need a space in here. What if I put a quote here and say good space, boom, and then do that, we get what we're looking for. Generally, you can use either double quotes or single quotes if we want to introduce white space. So either one will work the same way. All right? Now, the ability to send output to the standard output to the screen can be enhanced by the use of an operator greater than. And the name of this operator is output redirection. It has a name. So basically we can say whatever was intended to go to the screen can now be redirected into a file. So let's try this. We're going to say echo good dog and place it in a file called kennel. And we get a message that says the file exists. So let's take a look. Do we have a file called kennel? Yes, we do. So it looks like this command will not work if the file exists. So why don't we just erase the file and do that command again. And let's see if it works. All right. Let's also try to add something to it. What would say echo bad cat and place that in the kennel. It'll say we can't do that. So why don't we see what's in the file kennel? We can just say cat kennel. Cat is a command that displays all the contents of a file to standard output. So we can say good dog is there. Now, what can we do? Turns out that we can append to an existing file by the operator greater, which is append. So now let's just say echo to produce output bad cat. We don't want the output to go to the screen. If so, we would have hit enter. This time we want to say stick it to the end of the file kennel. Now we need to see what's in kennel. What's the command to display what's in a file? Cat kennel, pardon the pun. And now we see that we have actually built a file. If I want to add lines to kennel, I'll just do that same operation, echo append to kennel. Why are we talking about this? For some of the testing that you're going to do, you need to create a file that has lots of stuff in it. We can manually create these files as your program runs by issuing these commands from inside your Unix program. All right? We're going to stop there. Okay, why don't we look at one more feature and then we'll go. What if, no, let's skip this. Let's not do that. Now let's switch our attention to how we do some of these things inside your program. My bad. Go. Inside, in C++ and in C, there is a function called system. The function takes a string, which is a Unix command, and it will perform that command as if you were typing the command from the keyboard. So the command system ls is an ls command. These commands will delete a file. Notice that there's two versions here. If I say remove bad file, if the file doesn't exist, you'll get a message. If I say remove -f, -f means force it. It will not give you a message. So if the file isn't there, it won't delete it. If it's there, it will delete it. All right? Notice that I can also do a system command where I use output redirection, because the command says produce an output line that contains 1, 2, 3, 4, and instead of putting it on the screen, write it to a file. And that, again, as we have seen, this will create a file called new file. This command will put on the screen what is inside the file and so forth. All right? So let's move forward real quickly and look at the actual program that we have. Remember, we had two things called Unix. One is a program, sum3, and let's take a look at what sum3 looks like. Keep it back. So here's sum3. I'm going to extend this so we can see what we have here. Okay, skip over all this stuff. And of course you can take this file and run it yourself. And let's see what we're going to do. We're going to make an input file called 3nums, and we're going to put 8, 2, and 4 in that file. So when we run the program, we're going to announce what we're trying to do. And we're going to see that to create this file, what are we doing? We're erasing the file so that we can redirect output into that file. Okay? So we're making sure we have a clean slate. Then we will create the file and put 824 in it. Next, we're going to actually open the file and read it. Then we're going to echo to you what values we read from the file. And we expect to announce that we read 8, 2, and 4. The next step, we're going to display the sum. Next, we're going to display the sum and write it to an output file. Now finally, we're going to verify what we wrote to the output file from inside the program. So let's imagine what's required there. Well, it sounds like we need to do a Unix command that will display what's in the output file. But we know what that command is. It's cat, isn't it? So instead of typing it from the command line, we're going to use the system call to say what it is. So basically, this first one is going to say, put on the screen a little label that says file sum of 3 comes below, and then we're going to display the file. All right? And the next thing we're going to try is we're going to try the same as before, but this time we're going to try to put a label on the output file so that it is not below, but it is on the side of the label. Why don't we just run this and see? I think this thing is called S3. Let's just compile it. Sum3. Okay, and we're going to run it. Going to go real fast. S3 dot run. And we got all this output. Let's take a quick look at it and see what it looks like. All right. So what we have is all that you saw in the code. We're executing the program. We're going to do this command first. It's going to create an input file. When the program reads the file, it says we read 8, 2, and 4 from the file. We calculate the sum. Then we store the sum in the output file called sum of 3. Inside the program again, we are displaying what was in the file because we did a cat command. And finally, we're displaying what's in the input file. All right? And we're displaying it two ways. This way, the input file comes below this line. This way, the input file occurs to the left of the data. Excuse me. This is a label right here, and this is the content of the file. In the other case, we have a label and the content comes below. Often you will find that, especially if the file consists of just one line of something, it's better to put a label and the file content on the same line. That makes it easy to visually inspect and match things. All right, with that, we're going to stop and have at this and enjoy it. Thank you. Bye-bye.